Hello and welcome back. In this video, we're going to talk about object-oriented programming, one of the most important topic when you start learning or start understanding programming. Okay, so what exactly object-oriented programming is, and what are other type of programming techniques we're going to understand in this. We are going to talk about what are the generations of programming. Okay, like what was the first programming language or first programming system, or programming language that was invented, what type of language was that, and what are different type of programming paradigms. Okay, so we're going to discuss this in this particular. You can switch to that particular topic according to the timeline below. Okay, so now introduction, what exactly programming languages is. Now prior to understanding what exactly programming language is, you must understand what exactly algorithms are, what exactly flowcharts are. Okay, because if you start understanding programming or programming concepts, you must know these basic things like understanding algorithms, understanding flowcharts. How do I write particular programs without writing codes? Just by pictorial representation of the code, I'm going to go from this to this, writing pseudo codes. Okay, I'll make a separate video on that topic also, but now here I am with programming language. So what exactly programming language is? Programming language is a language which is specifically designed to express the computations that can be performed by a computer. What the other steps, or what are the programs that can be performed by a computer, by which we tell the computer to do this particular instructions, is nothing but programming language. So a selection of language, there are many languages, of course. Okay, we have Fortran, we have C, we have C++, then we have Java, then we have Python, we have many languages. Okay, but what particular language to select when I'm writing a particular program? So this depends on following factors: that the type of hardware and software on which your computer is to be executed, your program is to be executed, what type of program you are running, then what is the expertise of that particular programmer. Okay, what that programmer is expert in, like someone is expert in Python or Java, so that particular person is going to write programs in Python or Java, right? So what particular expertise we have in our programs, and then features to write the applications, what are the particular features that you want your application to have, and portability, like if I want to write for a single PC, then we're going to use separate language. If I want to have it multiple systems, then I'm going to use different programming language. Okay, so portability, then lower development and maintenance cost, and much more. So it must have lower development, and maintenance cost must also be low. Okay, so these are different factors on which the selection of writing a program depends. Okay, what exactly are the user requirements? Okay, so this is the thing. Now let's move directly to a topic that is generations of programming language. There are 5 generations specifically. So we have the first generation, that is which includes machine languages. Okay, if I give you an example, I guess it is Fortran, which is a machine language, or BASIC is a machine language. Then we have assembly language as a second generation. Then we have high level languages, that is third generation. Okay, third generation language. Then we have very high level generation language, which is the fourth generation. We have the fifth generation language. Okay, fifth generation is basically related to artificial intelligence and stuff like that. Okay, Prolog is an example. Visual Basic is also an example of fifth generation. Python is a third generation, which is having some of the characteristics of fourth generation. You're going to see every generation in detail. Let's start with the first generation, that is machine language. Of course, the word suggests us it is a machine language. Of course, every language is a machine language, but this is specifically a machine language which is using binary. Okay, that is just 0 and 1. So machine language are used to program the first stored program computer system. Okay, it is the first program which is stored on a computer system. So we have machine language. Okay, so this is the lowest level programming language, and it is also it is the only language that a computer understands. Okay, of course, machine language is only the language which computer understands. What our compilers and editors do, they convert our language into machine language. So but this was the first generation language, which was just a machine language. It was not anything. Do you understand? So what are the advantages? There were, yes, there were some advantages. What were they? Codes can be executed directly by the computer. Okay, we don't need to convert it to a machine language and then execute it, but the codes were directly executed by the computer. And of course, if you are not converting anything, then execution will always be fast and efficient, and programs can be, sorry for the typo, programs can be written to effectively utilize memory. Of course, we're going to take less space because we're not going to add much files in it. Okay. Disadvantages: code is of course difficult to writing with zeros and ones. Okay, difficult to understand of course, and difficult to maintain of course. Moving towards the second generation, assembly language. It is also called as 2GL, that is a second generation language. Okay, assembly language is a symbolic programming language that uses symbolic notations to represent machine language instructions. So now this is also machine language, but it has some symbolic notations which represents that machine operations. Okay, like we have jump, which is going to do jump from this step to this. We have loop kind of statements. We have move statements. Like this is an example, move. So this is a basic code. Try finding more about this assembly language, because this is, I found it very interesting when I learned about it. Okay, so we have move as our command is going to store our fourth value to the register of AX, which we are directly dealing with the CPU. We are not going to store it in particular location, stuff like that. We are just telling it, the computer, that you should directly store this 4 value to a register AX, then similarly move B and this, and we have an operation add, okay, which is going to add these two. Okay, and it is going to store in AX. Okay, whatever you put over here, it's going to get stored in this. Okay, so this is it. So this is very interesting language, I suppose, but it has some advantages and disadvantages also. So it is easy to understand, as you can see, like we want to move something in something. Okay, similarly it is easy to modify, it is less prone to error, and it is easy to detect errors, and it is easy to detect and correct errors. Of course, we have very few lines of code if we want to write small operations, and we just like if I did some errors, I can detect it very easily. But what are the disadvantages? Code is machine dependent, and thus is not portable. So if AX is a register on my PC, it is not compulsory that it will be free on your PC also. Okay, so code is machine dependent and it is not portable. One of the most important feature when you write a programming language is that it should be portable. We have seen. Okay, so code is in machine dependent and thus it is not portable. So program must have a good knowledge of the hardware internal architecture of the CPU. So you must know what are the registers in the PC and stuff like that. Okay, so it is the programmer must have a good knowledge of hardware. Okay, internal architecture of CPU and stuff. Now there is the third generation also, which is a high level program. Okay, high level language. Okay, the second generation brought logical structure to software. As you can see over here, we are talking more about logic, like adding this into this register and moving this particular value to the register, moving this value to the register, and this will add. There's some logic. Okay, so second generation brought the logical structure to the software, but third generation introduced to make these programming languages more programmer friendly. Okay, do you get that? Means in this generation we became more friendly towards our programming languages. Okay, now examples of these languages are BASIC. Okay, this is BASIC, Fortran, Pascal, COBOL, okay, C++ and Java. These all are okay. So machine language is not Fortran, BASIC, or whatever I said it at the time, but machine language is just a language where binary zeros and ones comes. Okay, so third, we have a second generation language that was assembly language, and then we have a third generation language where these languages come into play, that is BASIC, Fortran, Pascal, COBOL, C, and C++ and Java. Okay, so what are the advantages of the third generation? That it is machine independent, like I can transfer, it is portable, it means that I can transfer from one machine to another. So code in machine of course is independent. Then it's easy to learn and use the language. Of course, we know how to write code in C++ or Java. It is very much easy to understand and readable also, mostly I say. There are few errors. Okay, we can detect errors basically, and it is easy to maintain also. If I want to add some more program on C++, I can have it. Okay, what are the disadvantages? Code may not be optimized. Okay, it is very much difficult. If you want to optimize your code of sorting, you need to understand what a bubble sort is or what binary sort is, stuff like that. Okay, so you need to understand how you can optimize your code. Okay, because here we are not just talking directly to machine, but we are converting. We have an interpreter in between us. Okay, so we want to convert it and then we want to present it to a machine. Okay, so it is very much it is not we want to optimize it so that computer or our PC machine gets it very easier to understand. We can see that. Okay, the code is very less efficient. Of course, there is some efficiency problem in every code. Okay, it is difficult to write code that controls the CPU, memory and registers. Okay, we here in C++, Java, COBOL, Pascal, Fortran, basically we are not directly connecting with communicating with registers or CPU architecture, internal architecture and stuff like that. Okay, so it is difficult to write code that controls CPU and stuff like that. Now, fourth generation is a very high level languages. So with each generation, programming language start becoming easier to use and more similar to natural language. Of course, we can take an example of Python. Python is one which is third generation also, but has the use of fourth generation or uses attributes of fourth generation also, because Python is easy to understand and it is just like a natural English language. Okay, so 4GLS, that is fourth generation languages, are little different from the prior generations because they are non-procedural. We're going to see what exactly procedural languages means, what does object-oriented language means, okay, data-based languages means. So they are little different from the prior generations and they are non-procedural. The characteristics, what are the important characteristics of fourth generation language? The instructions of the code are written in English, like sentences. You can take an example of Python. They are procedural, so user concentrate on what instead of how aspect of the task, so it is non-procedural. We're not going to talk about we're going to talk about what we want to do instead of how we are going to do, because we know how it is done. Okay, because when we talk about assembly language, we need to understand how we are going to do this, but when we talk about Python, it is easy, same what you want to do. Okay, and the code are easy to maintain and stuff like that. Now, talking about the fifth generation programming language, the fifth generation programming language 5GLS are centered on solving problem using the constraints given to a program rather than using an algorithm written by a programmer. Okay, it's very much important because fourth generation is related to your AI and stuff. See, these languages are widely used in artificial intelligence. Like, we are not going to understand in this programming languages, we are not going to understand what algorithm is, but we need to understand what constraints are, on what range we are going to do this program for. Okay, so examples of 5GLS are Prolog, OP, S5, Mercury and Visual Basics, as I told you. Now, thus taking forward leap, if you talk about more 5 years or let's say 2 to 3 years, 5GLS are designed to make computers solve a given problem without the programmer. Okay, now for solving programs, you're not going to get programmers, but we're going to get computers. Taking forward leap. Okay, so this is it for generations. We cannot talk about advantages and disadvantages of fifth generation. Of course, this one is an example where we are not going to need programmers to solve, but computer itself is going to solve this problem. But the disadvantages are not yet cleared, so let's not talk about that. So fifth generation programming language, these were the generations of programming language that we have discussed. Okay, so we have first generation, that is machine language, pure binary numbers. Then we have second, that is assembly language, where we have some logical symbolic representations of operations. Okay, like add, sub, mul, div. Okay, then we have the third, that is the third generation, where where we come that it is procedural dependent, third generation high level language. Okay, we had some advantages and disadvantages. Then we have fourth generation, and now we have fifth generation, that is dependent on artificial language. So Python is my language, and I'll say that Python is the language which is the third generation language, but it has fourth generation properties, attributes. Now, programming paradigms. What are paradigms? There are different styles of writing programs. Okay, so fundamental styles of programming that defines how the structure and basic elements of the computer program to be built. Okay, how we are going to build that particular program, we're going to define in this. Okay, or it is defined in using this programming paradigm. So there are different type of programming paradigms. These are, and we're going to discuss 4 of them: monolithic programming, procedural programming, structured programming, and object-oriented programming are the programming paradigms which we're going to discuss. What is monolithic programming? It is emphasizing forever on finding a solution. Okay, we're going to focus on finding a solution. Procedural, we're going to lay stress on algorithms. We want to understand algorithms, then only we will be able to solve the problem. Okay, so that is procedural programming. Procedural programming is nothing but function dependent programming. Okay, this is the this procedural programming is where function come into play. We have structured programming which focuses on modules. What is structured programming? If I want to summarize it, so structured oriented programming is, or structured programming is where we write a code and save it, and then we use it, reuse it wherever we want. Like in Python, if I talk about let's say NumPy. So NumPy is a module, or it is a package though, but it is a module, let us suppose, which is having different type of functions in it. So it is a module. Okay, so structured programming is focusing on modules. Then we have object oriented programming, is the basic one, which is the important one for right now. So object oriented programming, it is emphasizing on classes and object. It has an emphasis on classes and object. Then we have logic oriented programming, which focuses on goals usually expressed in predicate calculus. Rules oriented programming makes use if then else rule of computation. Then we have constrained oriented programming, which utilizes invariant relationship to solve the problem, whatever. So these 4 are important: monolithic programming, procedural programming, structured programming, and object oriented programming. Okay, so let's move towards monolithic programming. What is monolithic? The word only suggests you're going to use a single thing. Okay, and that single thing is a program. So mono. Okay, so programs within are written using monolithic programming languages such as assembly language and BASIC consists of global data and sequential code. Like, I'll give you an example. This is an example. So this is a global data and this is a sequential code. So there is a disadvantage, of course, because we just have a data which is global and anyone can modify that data. We don't want that, So as the name suggests, monolithic programming has just one program module. It is just single module. Okay, as such programming language do not support the concept of subroutines. What is subroutines? Like dividing the problem in small chunks so that one person solves this problem, other person solves this problem, and stuff like that. So it does not support the concept of subroutine. So this is just what the monolithic programming will be. Okay, you do some sequential code. Okay, like jump is an instruction, and then you have a global data, but here global data is not safe, right? This data is not safe because anyone can access it and anyone can change it, which we don't want. So monolithic programming is don't use it. Then procedural programming, but though monolithic programming might be used somewhere else. Okay, then we have procedural programming. In procedural programming, a program is divided into n number of subroutines that access global data. To avoid repetition of code, each subroutines perform a well-defined task. Okay, I'll tell you an example. A subroutine that needs the service provided by another subroutine can call the subroutine. Therefore, with jump, go to, call instructions, the sequence of the execution of the instructions can be altered. Like this is an example. We have a global data and we have small programs or sub programs, because these are nothing but subroutine. These are divided so that they perform a well-defined task. Okay, like we want to build a calculator, so one model is going to contain or one function, one subroutine is going to contain adding, other contains subtraction, multiplication, division, and stuff like that. So we have subprograms and we have global data. Now let's talk about, of course, it's going to have some advantages and disadvantages. So advantages, the only goal is to write correct program. Okay, and it is easier to compare, it is easier as compared to monolithic programming, of course. Then we have disadvantages also, like writing a program is complex, of course, because we wanna write the same code multiple times. Okay, no concept of reusability, so we are not able to use that particular program. We are just writing once. Okay, requires time and effort to write programs and difficult to maintain, of course. Okay, so because we have different things, we don't know where error is, we need to go through all the program. Okay, like if we have error in subtraction, we will not be able to get, because we're going to go through all the lines of the code that we have written. Then we have structured programming. Structured programming is also referred to as modular programming. Okay, I'll tell you an example similar to procedural, but there's a slight difference. Specifically designed to enforce a logical structure on a program to make it more efficient and easier to understand as and modify. I'll tell you, structured programming employs a top-down approach in which overall program structures are broken into separate modules. These allows the code to be loaded into memory more efficiently and also be reused in other programs like this. Okay, we have the global data, and these are different modules. These are different functions. So modules have their own local data, which is going to share the data of global. Okay, which is going to share global data. This particular chunk will be reused in this, let's say. Okay, similarly we can use reuse this particular modules or functions. Then what are the advantages? Each module perform a specific task. Of course, add is going to perform add a task, subtraction is going to perform subtraction. Each module has its own local data. Okay, you know what exactly global and local means. Okay, if you don't, you can move towards my functions second video, I guess, where I talked about global and local data. Structured programs were the first to introduce concept of functional abstraction, so I was wrong. Structured program are the one who introduced the process of, or the concept of, function abstraction. What is functional abstraction? It allows a programmer to concentrate on what a function or a module does and not what or not how it does. Okay, so this is it. So function abstraction was from here. Now then it takes less time. What are the disadvantages? Structured programming is not data centered. Its main focus is on function, and global data is shared and therefore may get inadvertently modified. Okay, so global data is shared, so it can get modified anywhere in the program. So this is also not accepted. Now all the disadvantages I get is being overcome in object-oriented programming. This is what our video was about. So okay, so this object-oriented programming is going to have series of videos. We're going to talk about different type of features of object-oriented programming separately. Okay, each feature can have multiple videos also. So now what exactly object-oriented programming is? OOP. Oops. Okay, topic is said. With the increase in size and complexity of program, there was need for a new programming paradigm that could help to develop maintainable programs. Okay, like this, we have objects everywhere. Okay, we can reuse these objects whenever we want. So object 1 can be connected to object 4, 2, 3 and etc. Okay, so object of the program interact by sending messages to each other. Okay, so OOPs treat data as a critical element in the program development and restricts it to flow freely around the system. Okay, the object or the data is very critical. The data, it is focusing on data rather than what attributes we can say. Okay, because data is centric, because we understand like data is important and it must not be shared. Okay, so data is a critical element in this programming paradigm and it restricts it to flow freely around the system. So we create objects for this. Okay, so that the object can only use the particular part of the program. We will see, okay, in future videos what I exactly mean. So O, or that is object-oriented programming paradigm, is task-based and data-based. So what you want to do and in which data you want to do that is important. In this paradigm, all the relevant data and tasks are grouped together in entities which is known as objects. So all the data is going to get grouped together in the entities which is known as objects. Okay, like let us say you have an array. Okay, you have an array and you want to perform some specific tasks on this. Okay, you have an array, consider a list of numbers, okay, which is stored in an array, and what the procedural or the structural programming paradigm considers this list as merely a collection of data. Okay, but that any program that accesses this list must have some procedure or functions to process this list. For example, if you want to find the largest number, or let's say if I want to sort the numbers in the list, we need specific procedures or functions to do that task. But therefore, the lists are passive entities, as it was maintained by controlling programs rather than having the responsibility to maintain itself. It is not maintaining itself, but it is working on it. But however, in object-oriented paradigm, the list and the associated operations are treated as one entity, which is known as an object. Okay, so here list and the associated operations like sorting or like adding an element, these are considered an object. Okay, in this approach, in the approach of object-oriented programming, the list is considered an object consisting of list along with a collection of routines that you want to manipulate in the list. Okay, for manipulating the list. So the list of object, there may be routines for adding a number to the list, deleting a number from a list, okay, sorting the list, and etc. Okay, moving forward, like the striking difference between OOP and traditional approaches is that the program assessing the list not need contain procedures for performing the task, rather it uses the routines provided in the object. Whatever you say is the object, that is the operation that we want to perform in the particular, rather than performing the whole task. Okay, so therefore we conclude that object oriented programming is the task based as well as data based. So we want to specify by using object that what operation you want to do on which data you want to do. Okay, so as you can see, this is an example. Like here, this figure represents the generic object in the object-oriented paradigm. Every object contains some data and operation methods as a function. So this is data, and these are the functions that we want to perform in it. Okay. While some objects may contain only basic data types such as characters, integers, floating types, and other objects, on the other hand, may incorporate complex data types such as trees or graphs, which you will understand future. Okay, program that need object will access the object's method through a specific interface, and this interface specifies how to send a message to the object, that is a request for a certain operation to be performed. So before performing that particular operation, you want to request that particular class or object to perform that, and there it is having a particular interface. Okay, so what are the striking features of object-oriented programming? It is data-centered. Okay, data is important. Program is divided in terms of object and not procedures. Okay, data is hidden and not accessible to external function. Okay, this data is private data. It is not accessible by functions. So we're going to work on variables first. Data will be given is always private. Follow a bottom-up approach for solving a problem. There are two types of approaches: top-down approach and bottom-up approach. I'll make a separate video on that. Till that time, you can search on Google. Okay, so it does follow a bottom-up approach. Okay, now what are the features of object-oriented programming, which we're going to talk about in separate videos? Okay, like the object-oriented programming must support the mechanism to define, create, store, manipulate object, and allow communication between objects. Okay, as I told you, it communicates, different objects communicates with each other. Okay, so what are the different mechanisms by which we can communicate between two objects? Yes, we have classes, we have objects, we have methods, we have message passing. Then this is important, like inheritance, polymorphism, contourship, reusability, the delegations, and data abstractions and encapsulation. So data abstraction, you can understand how you can abstract the data, how you can encapsulate the data. Okay, how do you inherit the data from the classes and objects? Okay, polymorphism. Okay, overriding and stuff like that, because these are all the features of object-oriented programming, which I'm going to start in this object-oriented programming series, specifying for specifically for Python language. Okay, so this is for this video. Thank you for watching. Do like, share, and subscribe so that you never miss another update. Okay, another video. And if you are studying data structures and algorithm, the second step to Python, or second step after learning programs, do visit my blogspot eatsleep-code-repeat.blogspot.com, where I write about where I have written about DSA, a plan where you have a perfect plan for learning data structures. Okay, And by this I'm signing off. Bye bye. Thank you. Come again.